So in this video, we're looking at the long profile of the river, trying to understand how the river's characteristics change from source to mouth. These are the important terms. Hydraulic action, this is the water driving air into cracks, the air forcing the cracks open, widening the cracks, breaking up the bed and the banks. Abrasion, this is where load, rocks, pebbles, sand, carried by the river, drag along the bed, crash into the banks, eroding it as they go. Attrition is where the load actually crashes into itself, so different particles, maybe small pebbles hitting bigger ones, or sand crashing into other pebbles, making the load smaller, smoother and rounder. Corrosion is a chemical process. This is where river water, which is likely to be slightly acidic, is passing over rocks, some of which, for instance limestone, will be dissolved by that acidity. You might want to pause here to see if you can work this one out yourself. Hydraulic action, well, that's picture C. The water is driving into these cracks, driving air into these cracks. The air under pressure forces the crack open. Abrasion, well, that's picture B. The angle grinder here is being used to grind material off the surface of the metal table, that red thing. Well, that's kind of like the rocks hitting the bed and the bank. Attrition, well, the results of attrition are shown in D, where the pebbles, as we move further and further downstream, this is the downstream direction, the pebbles are getting smoother and more rounded. And corrosion, that's what we've got in A. Up in A we can see that this rock, which must contain some iron, in some places seems to be rusting. And that's because it is rusting. The iron turning to iron oxide, which is this red rust. Here we've got the long profile of the river. On the left hand side, where it's labelled source on the x-axis, we can see that the gradient's very steep. This is up in the highlands where it's very steep. Here, because it's steep, the water has a lot of gravitational potential energy, so it's got a lot of energy for erosion. As we head down along the long profile of the river, the slope becomes shallower. This means that the river has less energy to carry out erosion, so while erosion may be dominant in the upper course, up here where there's a steep gradient, as we get lower down, transportation and then deposition become much more prevalent. Again, another point where you might wish to pause. If you read the text on the left hand side and have a look at the images on the right, what you're trying to do is find where each of these things belongs. Which of these represents the upper course where the gradient is steep, which represents the lower course where the gradient is shallow, and which one middle course. Well, here we got the upper course. The valley has a steep gradient. The valley floor is steep. The river has lots of energy to erode downwards, and that produces this V-shaped channel. At this part of the river, actually, the river channel fills the whole valley floor. That belongs up there. Here, we're in the middle course. The river's getting wider. It's also getting deeper. These aren't to scale, so the river in this place is much wider and deeper than here. The discharge is greater. This one belongs in the middle course. The river's starting to erode laterally. Finally, we've got wide meanders, alluvium, which is very fertile sediment, soil, being deposited by the river in the lower course. Here we can see a river in the lower course, meandering widely. What we can also see is that this point might soon cut off. This would then be called an oxbow lake, if the river here cuts through this meander. We can see that it's happened many times before. Out here we've got former river channels. Here we've got abandoned meanders that used to be part of the river channel but aren't anymore. In this lower course of the river, it's possible for the whole river channel to migrate back and forth along the floodplain. Where does this belong? Well, the land is quite steep. The river is being forced back and forth between spurs and re-entrance because it's quite small. It's eroding downwards, causing this V-shaped valley. That's what tells us that this is the upper course of the river near the source. River filling the valley floor, V-shaped valley, river being pushed back and forth by re-entrance and spurs. So spur here, spur there, spur there, spur there. We'll call this interlocking spurs. Here on the Shatt al Arab, in the very northern part of the Arabian Gulf, here we can see a huge floodplain on which this city's been built, and part of the floodplain on the other side. This is on part of a wide meander, and at this part of the river we expect rivers to meander greatly. As you can see from the scale here, from the size of these ships, this is a very large river. Discharge is very high. We've got a wide, deep river. Surface velocity, it doesn't look very turbulent, and it isn't, but it is flowing much more quickly than it would have in the upper course. Here we're in the middle course. How do we know that? Well, we're not in the upper course because the river doesn't fill the whole valley floor anymore, and the gradient is somewhat less steep than it was before. But we're not in the lower course. We've got these steep slopes on or around the floodplain, and while the river has started to meander, it's not meandering very widely. We can also see in this area that we've got relatively large pieces of sediment, which is also kind of a giveaway that we're still only in the middle course and not in the upper course or the lower course. So what's happening as we move from source to mouth? Well, width, distance across the river from bank to bank, depth, usually expressed as either at the deepest point, also called the Fauweg, or the average depth of the river. Then we've got the velocity of the river, and then we've got the discharge, which is the cross-sectional area multiplied by its velocity, and then what happens to the gradient or slope. Well, as we move down the river, it gets wider, it gets deeper, and if it gets wider and deeper, this is because there's more water in the river, because the tributaries are joining up, making for a bigger river. The velocity is increasing too. It's a much more efficient channel lower down. So even though it's got less energy, because the channel is more efficient, it'll move faster. Now if it's going faster and there's a larger channel, well, discharge is going to be greater, and the gradient, well, that's actually getting smaller, isn't it? Because we're not in the upper course with steep slopes anymore, we're in the lower course close to the mouth where it's much more shallow. And finally, this is something that you need to research yourself. Find a photograph which you could print out, or you could sketch it into your book. You need to find pictures of interlocking spurs, a waterfall, a meander, a river cliff, an oxbow lake, floodplains and levees. You can probably find them on the same one. For each one you need to sketch it into your book, or print off and paste a picture into your book, and then you need to annotate it to show where these features are on it.